to give a special welcome to Professor Will Stephan, a key speaker for the Sustainability Festival, and a welcome to all in attendance today. Before we start, I would like to pay respect to the Ngunnawal people, whom I acknowledge are the traditional owners of this land on which we are meeting, and pay respect to the elders past and of the Ngunnawal Nation, past and present. I extend this respect to any Indigenous people in the audience this evening. As the UC Sustainability Planner, I'm pleased to introduce our Sustainability Festival Beyond the Centenary Visions or Voices of the Future. This week-long festival commenced yesterday with a coordinated discussion between the Property Council and the University of Canberra that looked at the business proposition of sustainability. It looked at it not only from the perspective of green buildings and the economic decisions that provide incentive for us to move towards sustainability, but it also looked at it from a teaching and learning perspective and how, as custodians of the next generation of leaders and professionals, universities have a special role to play in ensuring that our students have the sustainability literacy that allows them to take that to their discipline post-graduating from the university. This was followed by a political Q&A which provided some lively debate around the coming election and also specific sustainability initiatives as they relate to the ACT. Both of these events will be posted on the sustainability website for you to have a look at your own ease. We had a lot of other events throughout the week, and I do encourage you to take a look at the sustainability website. If you're up for some fair trade coffee, fresh squeezed juice and a nice hot or cold breakfast tomorrow morning for free, then I strongly suggest you get your leg warmers on, get on your bike, walk or bus to uni, and you'll be able to have a free breakfast between 8:30 and 9:30. And this will be followed by a sustainability trade fair where you can find out the amazing things that lots of different groups from NGOs to governments and also what your own university and students association are doing to progress the sustainability agenda. On Friday, most of you may have noticed that there has been quite a bit of landscape activity out in front of Sizzle. And on Friday, the signpost garden that students have designed and constructed on the University of Canberra will officially open. Now this is a pretty remarkable project because everything from the initial design through to the construction has been undertaken by UC students, not as volunteers but as part of their coursework. And it's been a really unique opportunity for the UC to show how we can embed the principles of sustainability into our teaching and learning program. So I strongly encourage you to get along to that as well. Now to the festival's keynote address, the Anthropocene, where on earth are we going? And I have the great pleasure of introducing Professor Will Stephan as our keynote speaker. Professor Stephan is a commissioner in the Australian Government's Climate Commission and is a climate and global change researcher at the Australian National University. He served on the Multi-Party Climate Change Committee in 2010 and 11 and is also chair of the Arctic Science Advisory Committee. From 1998 to mid-2004, Professor Stephan served as Executive Director of the International Geosphere Biosphere Program based in Stockholm, Sweden, and is currently a guest researcher at the Stockholm Resilience Centre. His research interests span a broad range within the fields of climate and earth system science, with an emphasis on incorporation of human processes in earth systems modelling and analysis, and on sustainability and climate change. Please welcome Professor Will Stephan.
Okay, let's get started with this concept of the Anthropocene. I'm not going to tell you right at the start what this has to do with sustainability, but you'll probably work that out as I go through. As you can see from the name Anthropocene, it's really got two parts. That end part, the scene, sort of gives you the idea that we're talking about long times, geological times. You've heard of the Pleistocene, or maybe even the Eocene or the Miocene. These were long eras or epochs in Earth history. The front bit of the word is anthropo. Well, that refers to us, anthropogenic. So Anthropocene is a new idea. It's only been around for a bit over a decade, that the Earth is now entering a new epoch in its history, the Anthropocene. But it's one that's been driven by one species, our species. So I'm going to take you on a tour of the Anthropocene, how it got started, how it took off, And the second half will be, where might we be going in the Anthropocene? So as I said, it has connotations of deep time and Earth history. This is the only slide I'll show you really of the deep time, but it's different time slices starting from 65 million years down to the most recent past. That top one, 65 million years, look at it this way. Dinosaurs just disappeared on the left of that graph. And as we go through time, the temperature, which is the vertical axis, slightly cooled over a long period of time. You see a little drop about 34,000 years ago. That's when we first got a big polar ice sheet on Earth. That's when the Antarctic ice sheet started forming. Then it got cooler and cooler, and down about 10,000, 9,000 or so years ago, we started getting the big Greenland ice sheets. That should be million years ago, not 1,000. About 9 to 10 million years ago, we got the big Greenland and Northern Hemisphere ice sheets. But really, us humans live in the next panel. Our ancestors, hominids, arose about 2 to 3 million years ago, which is on the left-hand side, and we lived in a very erratic climate. Ups and downs, swings and roundabouts, cold and hot, wet and dry, and so on. Then we take the last 60,000 years of that. You see that erratic pattern until the last 10,000 years. That's called the Holocene. That's the one right in the bottom panel there. It's an unusual period. And as I'll show you, it's this period that's allowed us to develop agriculture, villages, cities, civilizations that we know. So this is a quick tour through the history. I'm going to focus now just on the human part of it. And I'm going to start by going further south of here. That's to Antarctica. This is a picture from the Australian Antarctic Territory, due south of Hobart in the south coast of Australia. But scientists use this to study the Earth's past. So they go out away from the coast, right into the top of the big ice dome. And what they tend to do is drill as far down as they can go, sometimes several kilometers down. This is actually a small core that this guy's taking, but they have big machines to go all the way down. When they pull those cores out, they look like this. You can just see, if I can use the mouse, you can see the ice being extruded out of that tube. So that ice is layered. Because the snow falls, it's layered and layered and layered and layered and compressed. But the interesting thing is, it actually traps tiny bubbles of air in this. So we can actually tell what the atmosphere was like tens and hundreds of thousands of years ago. We can tell what the temperature was like. We can tell how dusty the Earth was. In other words, how wet or dry it was. Fascinating stuff. And that really gives us the history of what the planet was doing since we humans were on the planet. So this is from that area in Australian Antarctic Territory. This is what comes out when you plot the numbers. We'll only focus on the red line in the middle. That's temperature. Now it goes back about 400,000 years, close to 500,000 years. And you see a regular pattern. It's actually a little like a human heartbeat if you actually look at it closely. But that's, if you like, the rhythm of the very short, warm spikes, and then a descent into a long, cold ice age. Now, for fully modern humans, not just for hominids, but for fully modern humans, we can plot our entire history on this graph. We arose about 250,000 years ago during the depth of one of those ice ages, and we've come through 2 of those cycles, 2 warm period cold cycles. But notice that we were hunter-gatherers only until that little bit on the right-hand side that I've circled called the Holocene. That's the 10,000 year period where the climate stabilized and allowed us to develop our societies. So it's very important that we get this context in place here before we start talking about the Anthropocene. So if I look at the last 10,000 years and swap hemispheres, this is actually a Greenland ice core, but exactly the same principle. That's temperature, and that's the very erratic temperature during the last ice age. It was much worse in the northern hemisphere than it was down here because the ocean circulation was flickering up in the North Atlantic. Notice that 10,000 year period that I've circled there. Look at how even that temperature is compared to what went before. But this encompasses all the history of humans moving out of Africa. We got out about 85,000 years ago, around the southern part of the Arabian Peninsula, around South Asia, and the first migration ended up here. Well, it ended up here and in New Guinea. They branched at the end with the New Guineans and the Australian Aborigines arriving roughly 65,000 years ago. Those of us who have some European background come from 1 or 2 migrations. Our ancestors are actually South Asians. They come from present-day India. And some migrated about 55,000 years ago into the Mediterranean. Others migrated about 33,000 years ago into the northern part of Europe. So if you have Mediterranean background, Italian or Greek or whatever, your ancestors moved out of South Asia about 55,000 years ago. I have some Swedish background, and that meant that my ancestors spent more time in South Asia, only arrived about 30-some thousand years ago into Europe. But again, it was only through that warm period, 10,000-year stable period, that we first developed agriculture. And then villages, cities, the great civilizations on several continents from 2,000 to 4,000 years ago, and of course our contemporary civilization. And that's called the Holocene. One of the most fascinating pieces of data that's come out recently is an Australian piece of work that was only published about a month ago in a Royal Society publication. That is the population of prehistoric Australia going back 50,000 years. The dating technique, which is the carbon isotope dating technique, doesn't allow it to go back any further. The point is there were very low populations of Aborigines from the time of colonization, about 60-some thousand years ago, all the way through the Ice Age. The depth of the last Ice Age was about 20 to 22,000 years ago, and then it started slowly warming. Look what happened to the population as we went into the Holocene. Even though this is still a hunter-gatherer culture, it's clear that the Holocene is a much nicer climatic state for humans, whether you're a hunter-gatherer or whether you live with an agriculture-based society like we do. So that's another good piece of evidence that this is really a nice planetary state for humanity. So that's our base, the Holocene. But now we see some things are happening. All these pictures are from Australia. I could have got them from other continents. They're all within the last 4 or 5 years. And they all seem to be things out of the ordinary. We've always had fires, floods, cyclones, and so on. But something is happening. And it's getting people to think about, are we really destabilizing the planetary system? Are we in the Holocene, or could we be pushing out of the Holocene? Well, scientists have really systemized this over about the last decade of research. And a thing called global change, which includes climate change, but goes much beyond climate change. So here's the sort of things I'm talking about. That's the nitrogen cycle. You don't need to go through it in detail. The top panel is pre-industrial. The bottom panel is post-industrial revolution. Look how different it is. There's a massive great arrow coming down from the air into the land and sea, which is the bottom bit of those panels. That's industrial fixation of the nitrogen for fertilizer. We've massively changed the nitrogen cycle all the way through the system. We can look at the water cycle. Those dots are where there are large dams. And if you look around the world, virtually no river flows unimpeded, no large river, from the hinterland to the ocean. The only exception in northern Canada and northern Siberia. But everywhere else, we've dammed up every major river to speak of. Huge change to the way water flows around the planet. We can look at land. The colored in areas are the land where we grow our food and have intensive pasture, dairy, grazing. That's the intensive agricultural areas around the land. The bits that aren't converted are either too dry, like the Sahara, and most of Australia, or too cold, like Siberia, although that's changing now. And of course, climate is shifting too. It's being destabilized, and we see that most pronouncedly in terms of extreme events. That's tropical cyclone Yasi coming in on North Queensland a few years ago. Look at the size of that storm. It was a third to a half the size of the whole continent. Very, very big storm. So things are changing right throughout the world. And of course, we have the iconic graph that a lot of people are talking about now and studiously avoiding in the election campaign, which is what's happening to the Earth's thermometer, to the Earth's temperature. It's going up quite sharply, particularly since the middle of last century. So changes are afoot. So one of the things we tried to do when I was director of this program based up in Stockholm, which was looking at global change, was to say, all right, let's really unpack this whole thing. Obviously, a lot of things are changing. We know intuitively they're due to human activities, but let's actually make this very rigorous scientifically. So we produced these graphs. They all go from 1750, before the Industrial Revolution, to the year 2000. This work was done, by the way, in about 2002. So our data ended around the year 2000. And we had a linear axis for whatever we were looking at. Now, the thing I want you to know when we look at these is that year, 1950. It's a completely unique year in human history. Very important for the Anthropocene as well. So I'll start with showing you 12 of these graphs. They look a bit like an Andy Warhol painting, if you're old enough to know who Andy Warhol like I am. But that's what we call the human enterprise. This has nothing to do with the environment. It's us. It's what we do. It's how many we are, population. It's economic growth, how much we consume, how much we use in terms of resources, paper, fresh water, etc. And some other things like urbanization, globalization, transport, education. Look at those graphs. They all go from 1750. Look at 1950 on each one of them. We really changed gears after the Second World War as a global society. And you can see that for many things like McDonald's restaurants, which is our indicator for globalization, international tourism, and so on, it hardly existed before 1950. At the top right, we're foreign direct investment. Economies are now really integrated around the world, but not until 1950. Even population. Look at the change in slope of the population curve after 1950. So humanity took off. We often call it the Great Acceleration. That's what the environment happened to the environment. These are all global numbers, and the top 3 panels are the 3 famous greenhouse gases with CO2 on the left, ozone depletion, temperature, floods. And then the bottom 6 panels have to do with ecosystems, not with climate. They have to do with fisheries, marine ecosystems. They have to do with coastal systems. Lower left is tropical forest and woodland, the rate at which we're losing it. And the bottom right is the extinction rate globally, shooting up. So again, in each one of these, you see a very sharp change, often around 1950, but not always. The Earth is complex. It's buffered to some extent. But in each case, we can demonstrate that this is moving the planet out of the hole sun. If you go back 10,000 years, you don't see curves shifting this much in the past, with the possible exception of temperature that's being argued. But in everything else, we have no analog for this back in the Holocene. So this is some of the core data we use to make the case for the Anthropocene. I'll just show you visually what that great acceleration looks like. This is a graph that the popular American magazine, National Geographic, you see that. They did this. They did an article on the Anthropocene. They took a really simple equation. Our impact on the environment is some aggregate of our population, how many we are, our affluence. And affluence is a really good indicator for how much we consume. The more affluent we are, the more stuff we consume. And of course, the technology we use to produce the stuff. So that box is filled with stuff. You can see airplanes, cars, refrigerators. It's stuff that humanity uses. And the 3 axes are those 3 factors: population, affluence, technology, with affluence going up. Now you can see a little square down here, just in the corner. See that one right at the bottom? That's 1900. Okay. So that's after the Industrial Revolution got started, but it wasn't really taking off. And then they have 2011 at the top. Now I was an advisor to National Geographic on this figure, and they sent it to me and I said, wait a minute, you missed the whole story. I said, what? I said, put in 1950. And I said, why? And I said, I'm not going to give you the answer, put it in and see what you think. And of course, you can see the next little wedge just there is 1950. So in 50 years, we went from that little wedge to that little wedge. In the next 60 years, the box exploded. That's the Great Acceleration. And they hadn't thought of it. So I think it's important that we look at what happened. I could give you a whole lecture of what happened after the Second World War. Fascinating. But I won't, because I'll keep you here for hours if I do that. But anyway, this is where we see most of the impact after the Second World War. Interestingly, most of that impact was only by 20% of the Earth's population. By those of us who live in Australia, US, Europe, as the OECD countries. If we look at what's happening now to various countries, we can put the impact on a vertical axis, and that's what's called ecological footprint. So you see the USA up there? That's per capita, per person. African countries down here. So most of the Great Acceleration are these countries that shot up after the Second World War. And you see, look at Europe, the green ones, USA and Canada, and a few brown ones, which are Australia and New Zealand. Most of the world's population has sat down here. Very low footprint, but very low human well-being. This horizontal axis is a thing called the Human Development Index. That's index from 0 to 1. Most people reckon you need to be about 0.8 to have a good life for your population, so you want to be in this colored area. But this broken line here is basically one planet Earth. Once you consume more than this in terms of your footprint, like the USA people, about 5 times higher. That means that everyone would live like a USA person, you'd need 5 planet Earth to support us. So here's the problem. You see a curve developing, just like that. As countries develop, and a lot of them in Asia now are developing, and in Latin America, they tend to slide by this quadrant where we all should be, up toward the wealthy countries. There's only one country here, it's a Latin American country, that nicks the corner. It's the only country in the world that could be said to be sustainable. Start using that word sustainable now. So when you think about it, only one country out of 200 may be sustainable in terms of also having a reasonable life for their population. Sustainability also means you don't have a lot of people in poverty. So this is the dilemma you face in sustainability, particularly at the global scale, is you want the human population in here, but our present development pathway takes us sweeping up there. So you say, well, everyone aspires to be up here because it's a really good life. But that's being challenged now by some research too that says the wealthiest countries are now running into big problems. It's a topic that's particularly to the fore in the United States now, with lots of problems there. See that on the covers of Time magazine, particularly with young people. Some of the most interesting research in my view has been done by 2 epidemiologists from the UK, from England, Richard Wilkinson and Kate Pickett, a thing called the spirit level. What they did was deceptively simple, but really profound. They just looked at countries, not in terms of how wealthy they were, but what was the gap between the richest and the poorest. What's the level of income inequality? So all the countries on that graph were already wealthy enough that everyone in that country could have a good life. They're all OECD countries. Then they made an index of social problems. You can read what they are: homicides, obesity, infant mortality, imprisonment, teenage birth, things like that. Look at how remarkable that correlation is. Countries with low income inequality, countries like Japan and the Nordic countries, do really well. They have the lowest amount of social problems. Countries who have high income inequality, like Portugal and particularly the USA is off the chart. They're even worse than they should be. So this shows that they have some cultural problems as well as a simple income inequality problem. Notice that all of these countries have different cultures. Question?
Sorry, why is suicide up there?
As a social problem,
Yeah.
you don't want to have it. You would like to have a lower suicide rate rather than a higher suicide rate. Okay?
I think, do you think that would change the scale of it in suicide itself?
It's interesting to note that countries like Japan tend to have higher suicide rates.
That's why I asked.
But it's included. They would look even better if you took suicide rate out. So it is included. Sweden also has a high suicide rate, but there's a very, very good reason for it. Suicide rate peaks when it gets dark, and people aren't designed to live that far north, so they have trouble. Some have trouble coping with it. So it has nothing to do with their social system. It's a physiological reason. Japan must have a different reason. Could be partly cultural. But see, the interesting thing is all those are factored in, and yet even when you factor in different cultures, different latitudes, there's a strong relationship between income inequality and social problems. And Wilkinson and Pickett say it's actually genetical, it's wired into us. That we tolerate hierarchy, we have to have hierarchy to have a society work. But once income inequality gets too big, it's like a toxin that just erodes society itself. So again, this has sustainability implications. Can you have sustainability socially if income inequality gets too big? All right, second half talk, where are we going? That's the second part of my title, in the 21st century. Do we have a bright future of continued growth? Will we reach sustainability? Or are we sailing toward the global collapse? And that's a question none of us can answer, but I'll just put some trends over the first decade or so of this century and let you make your own decisions. Before I do that, I'm going to go back in time. Because humans have faced problems before. As I said, we've had societies and civilizations, agricultural based for 10,000 years. Many have come and gone. You see the Roman Empire, the Greenland Norse, Buddhist Empire in present-day Burma, and so on. These have been extensively studied. I'm not going to go into detail, but you have the Greenland Norse. It's pretty clear that after the medieval warm period in the North Atlantic region, and it got colder again
they disappeared very quickly. If you look at the Roman Empire, again, there are a lot of factors at play here, but again, they thrived during what was called the Roman climate optimum, period of stability and warm weather. When it started getting colder and rainier and more erratic, that added to their problems. This is the most interesting one. This is in North America. And if you've been over there, it's in the present-day Southwest United States. It's in states called Arizona and New Mexico. And this was a period of about 1,000 or so years ago. And there are three different civilizations which are represented by these names up here. All in the same region, different cultures. All faced exactly the same shock, which is a very long and prolonged drought, one they hadn't experienced before. Two of the cultures collapsed, but one of them did not. In fact, you can see this indicated physical suffering. These people came through. Little physical suffering, had to change their culture, but the transition wasn't too severe. These two collapsed with violence, terrible health, and so on. Same environmental shock. So this tells us that it's really what's inside of our societies, our values, and how we operate that give us the resilience we might need. So there's some explanations for why these societies collapsed. They get pretty complicated. The one I like, though, is the last one, Jared Diamond, who says, look, every society has core values. If those become dysfunctional, if the world around you changes, whether it's trading relationships or enemies or environment, and you don't have the wisdom to change your core values, you're liable to collapse. And that's what we need to think about in present-day society. These two historians really look at the Great Acceleration, the period we've lived through. I was born really right near the start of the Great Acceleration. All of you are embedded in the Great Acceleration. That's the only life that you know. But it's highly unusual. And yet one of our values is ever more economic growth, steady year by year, and so-called progress. History's not like that. Look at what's said there in red. We are always dealing with constantly changing patterns of adjustment to limits and conflict. That's what human history is. So we're living in an aberration now. And yet we think, plan, elect our leaders on the promise that we just keep doing this forever. And no human society ever has. So what's the Anthropocene looking like in the 21st century? Here's some things that are going on. Some big countries are now starting their great accelerations. China's the most obvious one. We all know that. India too, but other countries, South Africa, Indonesia, to the north, and so on. We're really wired up now as a world. You know, when I travel around the world for scientific meetings, I can get on the internet and contact people back at ANU, contact my family instantaneously, get on my smartphone, it costs me a fortune if I'm overseas, still do that, get information instantaneously from Australia and so on. We move money around that way. We're increasingly moving people and materials around. Are we reaching some peaks? Everyone knows about peak oil. Well, there's still debate about what that's going to look like and whether we're reaching it. But what about peak phosphorus? How many of you heard of that? Probably almost no. But yet scientists are now talking about, will we run out of phosphorus? Hugely important for growing food. And if we run out of phosphorus, that would lead to a collapse in population. Now, this last one's interesting. We've spent millions, hundreds of millions of dollars, hundreds of researchers, I think between 100 and 200 researchers, to synthesize a chromosome, one of the basic building blocks in our genetic code. This is a chromosome for the simplest form of life, a one-cell bacteria. And they've inserted it into that bacteria, and it's stuck, and it's worked. So we are very close to synthesizing life itself. Bear in mind that's a single-celled organism, the simplest type of organism we have. At the same time, we spend a fraction of that money on biodiversity conservation. And if you look at the extinction rates, purple on the left is the background rate, green in the middle is where we are, where we're going is the red on the right, that's a logarithmic scale. We're now 100 times at least over the background extinction rate, possibly 1,000. And we're going to go up by another 10 or 100-fold. And where is the effort? This is the richest genetic code we have. It's already there. It's the information bank that operates the whole biosphere. And yet we're losing it at a rate that's only been seen 5 other times in Earth history. And yet we spend hundreds of millions of dollars to make one chromosome for a lousy one-celled creature. You wonder where the priorities really are sometimes. All right, food price spike. Here's an example of how connected we are. The top panel there is the price of oil, crude oil, and if I can give the scale right there from about the year 2000 on to 2011 or 2012. The bottom one, which is designed to line up in time, is food price, global food price for grains. Look how close those correspond to each other. Pretty close. By the way, many people now think that this second spike, was implicated around 2010 or 11 in the Arab Spring. Then when people don't have enough food or food prices go too high, politics gets wild. Just look at the French Revolution. That was a good example of where food prices went through the roof, people were starving, things got unstable. If you look at this from a systems perspective, you have what we call a cascading crisis. You had a really powerful, globally synchronous shock, oil price. But then people responded to it in a dysfunctional way. Russia, for example, saw prices go up. What did it do? It shut down exports. What did that do? It shoved prices up further, even in Russia, because it's still a global system. We had a bad drought, and so our exports were down. Small, but it fed into the shock, and so on. This is indicative of the sort of problems we face in the 21st century because we're so connected. You can read those problems on the left. Antibiotic resistance, connectivity, rising human numbers, international terrorism, and so on. You can see the shocks to the economy, our health, and so on. The thing that we don't account for very well is that most of these shocks have multiple drivers. It's not just antibiotic resistance that impacts human health. So does climate, so does terrorism, and so on. And then these broken lines, the actual shocks themselves interact, particularly with climate change interacting with the other ones. We as a society, even as a research community, have struggled to understand these sort of global shocks, but in fact that's going to be the norm for the 21st century. So I'm going to go back right to the end of my talk here and go back to the Antarctic ice core. And now look at this from a somewhat different perspective. That's looking now at the Earth itself as a system. So I said if you look at that, particularly that middle line, the temperature, that is very much like a human heartbeat. And so you say, well, was James Lovelock right? Is this one superorganism? Is this a Gaia-type organism? And the answer is, to a large extent, he was, because there's so much feedbacks and interconnectivity in the system. And the biosphere plays such a strong role, for example, in controlling the carbon cycle, that to a certain extent, yes, the Earth could be thought of as an organism. But we call it not quite that, we call it a system, and it's definitely a single system at the planetary scale. And it has all the qualities of a system. So we'll go through and look at what those might look like. First of all, it exists in two states only. A glacial state, that's those very cold periods, shown, and the very short warm periods, interglacial states. This is classic of a complex system. It is an oscillator between two states. Think of it like a pendulum that goes between two states and so on. It does it in a very, very regular interval. Those other two graphs I haven't talked about. The top one's actually carbon dioxide. Look at how closely carbon dioxide correlates with temperature. There's a relationship there. The bottom one is the other greenhouse gas methane. The thing's called limit cycles. I'll show you what they mean. So I shaded in there CO2. Notice that when it oscillates, not only is it regular in time, about every 100,000 years, it's capped at the bottom of the top from about 180 to 280 parts per million. That's called a limit cycle. Absolutely classic of a well-tuned single system. You can see limit cycles for the other ones. There's the one for methane. And temperature has a limit cycle. Okay? Now, enter the Anthropocene. There's CO2 today. That arrow is drawn to scale. Since the Industrial Revolution, we've broken that limit cycle. Not just by a little bit, but by a huge amount. That's what CO2 is today. That's where methane is today. Okay, we've broken that limit cycle. So scientists are really worried. We know it's a single system. We know that these are related. And we're going to shift temperature for sure. In fact, we are. And that's what's happening to temperature. Now, this is a 2,000-year global land reconstruction of air temperature over the land. You can see a very, very slight cooling trend through the Holocene, for the last 2,000 years of the Holocene, and then you see this spike at the end. That's the anthropogenic, that's the human-driven climate change that we're dealing with today. So if we look to the future now, these are the projections. You'll see them come out on the 27th of September when the next IPCC report is released. These are the ones from the 2007 IPCC report, and depending on how much more greenhouse gas we continue to emit, we could go anywhere up from a couple of degrees to 4 or 5 degrees by 2100. So that's what the graphs look like. The climate scientists do. It doesn't give you the right perspective. What you need to do is put that on the longer term perspective. That's what it looks like. So what I've done is I've put 2100 where it should be on that horizontal axis. I've put the lower IPCC estimate as that lower red arrow. And the worst case is the one at the top, to the right scale. Bear in mind that our society is adapted to that long-term temperature range, and so are ecosystems. The difference, by the way, between 1900, when that rise started, and the top arrow is about the same as between an ice age and a warm period. That's how big a shift it is in climate. And that's the track, by the way, we're on today in terms of CO2 emissions. It's why we in the Climate Commission call this the critical decade. And if we don't get this under control, by the time you're my age, you're going to have trouble. Physiologically, living in the planet will be the climate will be shifting so fast. There's the 2-degree limit. And that's if we're burning all fossil fuel. We have about 5 times more fossil fuel in the ground than we actually can burn if we want to limit climate change to 2 degrees. That hasn't hit the politicians yet. They don't like to think about that. Okay, what happens if you go above 2 degrees? Well, it gets pretty bloody hot, for one thing. A lot of animals go extinct. But also you start tipping the Earth system into a new state. And systems do this by parts of the system flipping. And science actually knows about what a lot of those look like. You can read them there, outburst of methane from the north. That's actually starting to happen up from the permafrost. We can see that. Ocean circulation changes. We start losing the big ice sheets. And so on, collapse the Amazon rainforest. We see signs of these instabilities today at a little less than 1 degree. And in fact, there's one group of scientists who think the whole biosphere can flip too. The whole thing. Not just an ecosystem here like the Great Barrier Reef and the Amazon, but the whole thing. And they reckon you can actually do it without flipping the climate. You can do it by just human modification directly of ecosystems. You see where we are in 2011 up the top there? So basically this is the percentage of the Earth's systems that are already showing state shifts. In other words, this dark ring is sort of intact natural ecosystem. No, it's the other way. The light ring is the intact ecosystem. These are the parts of the Earth that we are changing drastically into agriculture and so on. When we hit about half or a bit over half, we flip to the whole thing. Flip. And that's what the 5 great extinctions in the past look like. So there's an argument that we are somewhere here, where we're approaching 35–40% of the Earth's surface being modified. So what are the implications of the Anthropocene? If we look at this huge temperature spike that we're facing, and you look at this as a complex system point of view, the argument I would make is if we can limit temperature rise to no more than 2 degrees, which is the policy target of most countries, we'll probably still say in a Holocene-like climate, where the system itself has enough good feedbacks, dampening feedbacks, that it will return the Earth to a Holocene-like state over a long time, 1,000, 2,000 years, but we'll get back there. But if we cross a tipping point for the planet as a whole, which is made up of other tipping points like the permafrost, like ocean circulation, like the big poles, like the Amazon, if they start flipping around the 1 degree temperature range, then the planet will simply go to a new hot state, 5, 6, 7 degrees warmer, eventually with no ice at the poles. And we know it's stable because 35, 60, 70 million years ago it was just like that. It stayed that way for millions of years. So I think that's really ultimately what we're facing is we've destabilized the climate system, we've destabilized the biosphere, we've destabilized the nitrogen cycle. Up to a point, the Earth is resilient. It can tolerate that and keep it habitable for us. But if we cross a tipping point, then it's likely the Earth will move to a much rougher state for us to survive in. So that, to me, this is ultimately what sustainability is about, at least at the global scale, is we have to keep the Earth in a Holocene-like state. To do that, we've come up with a thing called planetary boundaries. I'll skate through this very quickly. It's these sort of 8 or 9 processes that we think can define the state of the Earth's system. And the idea is to keep it in a Holocene-like state by putting boundaries that we shouldn't push the planet past. We made an estimate of where we are That's the red wedges compared to the safe operating space, the boundaries of the green. And we think that for three of them, the ones I mentioned, nitrogen, biodiversity, and climate, we're already outside the boundaries. And that's why the Earth is starting to show signs of instability. And we need to pull it back to within that green circle. This is highly controversial. A lot of people around the world, policy people, don't like it because it says we can't keep doing what we're doing. I'll conclude then just with getting right back into the humanities, the human perceptions of this idea of the lost world of the Holocene, of the Anthropocene. It's interesting how people interpret, very culturally mediated. That's the French. That's Le Monde, covered their magazine a couple of years ago. How did they view it? Well, it had to do with eating and food, which is very important in French culture. So the Earth is a wonderful piece of French pastry or something. And our humanity here, our man is busily and happily eating his way through the planet, faster than the planet can regenerate itself. That's the French view of the Anthropocene. It's not a positive one. Well, we go across the other side of the Atlantic. What do you think the Americans would do? The age of man, bigger and better. Let's keep building taller buildings, more motorways. That was actually in National Geographic. That's their view of the Anthropocene. Now we're really in control. Let's run the planet. Well, as a scientist, you know you've really made it when the economist actually picks it up. So there's the cover of the Economist again about 2 years ago. Welcome to the Anthropocene. And of course, they go through a pretty good description of problems, but then of course, economics will solve it. I think really the interesting thing here is that this isn't the first time science has really confronted humanity. My colleague and good friend Catherine Richardson likes to point this out. You go back to Copernicus and Galileo, who were persecuted because they thought the Earth was not the center of the universe. They thought the Earth went around the sun. That was heresy. Darwin came along 200 years ago. And he said, wait a minute, we're nothing special. We're just a big ape. Yeah, we've evolved with opposable thumbs and a bigger brain, but we're a big ape. That horrified, still does some people, some parts of the world. So science does this. It challenges us. Brian Cox was in Canberra on Saturday night. Did anyone go out and see Brian Cox? He was talking about particle physics all the way up to the universe. He was talking about how time was one of the 4 dimensions. The question was asked, really is all this is physics seem to see, everything's predetermined. Is there any such thing as free will? And Brian sort of gave a very physical answer. He says, well, the future's already there. We just haven't got there yet. That's what physicists would say. So science confronts people. And the problem with global change or climate change or the Anthropocene is that it confronts the way we've done things since the Second World War, the Great Acceleration. Because we say it can't go on forever. The signs of destabilization are already clear. It doesn't mean we have to go back to caves like a lot of people say. It means we have to rethink the way we do things. And a lot of good can come out of that as well. So that's really the idea of the Anthropocene. It isn't the answer to sustainability. But it tells us really, really clearly that business as usual is not the answer, and we have to find another way. So I'm going to stop there, and hopefully we have time for a few questions. Thanks very much for your attention.